Right then, so today I'm going to be looking at power calculations. So just before I get into the power triangle and exactly what power is, I'm just going to go through these few little bits here. So, power is the measure of the number of coulombs times the voltage. So how many coulombs are passing per the volts. So power is a unit of energy, so it's always measured in joules. That's its base unit, joules. So 1 joule, which is equivalent to our power, is 1 coulomb times 1 volt. Or if we put it into an equation, W, which we measure power in watts, so it's in W, equals Q, which is charge, times our voltage, which is V. So just to explain this into a bit more of actual sense. So let's say here we've got all of these copper atoms with our free electrons all at the top. So for ease's sake, we're going to say that each one of these copper atoms is 1 coulomb of free electrons. Obviously it's not, because it's over 6 trillion free electrons in real life, but just for this diagram it makes a bit more sense. So let's say then we've got an EMF applied to this, with one side attracting the free electrons and the other side repelling the free electrons, so in normal cases of a battery. So as this EMF is applied, these free electrons move from atom to atom. So they jump from there to there to there. So as this one moves, this one becomes imbalanced, and then it pushes it onto there, and then goes onto there to there. So this here, this green line, as the free electrons are moving, as we already know, this is our current. Okay, so the voltage, the EMF, just pushes the current along. So it's not actually travelling through the circuit, it's just at the beginning of the circuit providing that force to push the current along. So as the current is going along, so the act of that free electron actually moving from one atom to the next creates our electrical energy. So our electrical energy in joules. And we measure this in watts. So as it's physically moving from one electron to the next, it creates this electrical energy. Okay then. So then next, we're just going to have a look at this power triangle. So this power triangle is the basis of all our power calculations, so if we've got a circuit. So we're just going to label it up. So P stands for power, I stands for current, as it always does, and V stands for voltage, as it always does. So we measure power in watts, current we measure in amps, voltage we measure in volts. So WAV. So just like the Ohm's law triangle, if we wanted to work out P, you put your hand over the P, and then the equation would be P equals I times V. So just to clarify that, this line here represents divide. This line here represents times. So if we want to work out power, it would be I times V. If we wanted to, using this triangle, if we wanted to work out current, just cover current up, it would be P divided by V. So next we're just going to have a look at our power calculation. So this is the first power calculation we're going to have a look at, and there's 3 in total. So I'll show you how we use all 3, and then I'll show you how we derive all 3 calculations, or at least the last 2. So on this circuit here, we've got a current of 14 amps and a voltage of 25 amps. So if we want to work out the power, P equals I times V. P equals I is our 14 amps times V, which is our 25 volts, P equals, so we're just timesing those together, and that is giving us 350, and we are measuring it in watts. 350 watts of power is being consumed, being dissipated by that circuit. So that's the first calculation, and this one only really applies to DC circuits, so circuits with a direct current such as a battery or a solar panel or something like that. So that's the first circuit, the first calculation. The second one is P equals V squared over R. So this one applies to AC and DC circuits. So for ease's sake, for the AC, I've drawn this wavy line which normally represents an AC circuit. So it's P equals V squared over R. P equals, so V squared is 20 squared divided by R, divided by 10. So it depends how you want to do it. You could just input it into your calculator straight away as the 20 squared, or 20 times 20, because obviously when we square it, we're timesing it by itself. And then that is 20 times 20 is 400 divided by 10. P equals 40 watts. Okay, so that's that calculation. So P equals V squared over R. And for our third and final calculation, it's P equals I squared times R. And again, this one works with AC and DC circuits. So we'll write out our calculation. P equals I squared times R. And I always think it's a good idea to write out your calculations in full. Not only can you see if you've made any mistakes, but it also, it's good to just get it into your memory as you're physically writing it out. So I squared will be 5 squared times 10. So P equals 5 times 5 times 10, because obviously that's your 5 squared. P equals 25 times 10. P equals 250 watts. Excellent. So that's the calculation for that one. So it's worth noting down all three of these calculations. It really depends, what calculation you're using depends on what values you've been given. So obviously if in a circuit you've only been given so you've been current and voltage, you're going to use this one. If you've only been given voltage and resistance, you're going to use this one. If you've only been given current and resistance, you're going to use this one. But now we're just going to go in how we get these two calculations, because it all goes back to this calculation and Ohm's law. So we've got these calculations here. So this is the basis of all of it. So let's say, for example, we're going to look at this calculation here, that we have got a circuit and we have only been given two values, which is voltage and resistance. So let's say we've got 10 volts and we've got 5 ohms. Okay. Now, because we are trying to work out power, and we know that power is current times voltage, now we've got a voltage there, which we can use for this, but we don't have a current, we've just got a resistance. But if we go into Ohm's law, we know that current is voltage over resistance. So we know that current equals V divided by R. So, and obviously here we've got voltage and resistance. So we're still trying to get to power, to work out power. But now we say, right, well, we can substitute this I for this V and R, V over R. But then we've also got V here as well. So it would be, instead of this I, it would be VR times V, because we've got this time on this line here. So V over R times V. Or, to write it out in a simpler way, P equals V squared over R. Okay, hopefully that does make a bit of sense. Let's get rid of that. So, if on our next calculation we've been given current and resistance, so let's say 10 amps and 5 ohms, and we want to work out power. So we've been given current, but we've not been given voltage, so we've not got voltage. So we want to work out voltage. So we know that voltage is equal to I times R. So if we work out our power, we go, so V equals I times R. So we're just I times R down to there. And then we've also got this I here, which is times in it, to get to our power calculation. So it's V equals I times R. Or to make it simpler again, P equals I squared times R. And that is how you get to those two variants of this equation if you don't have all the variables. So you're just substituting what you haven't got with the Ohm's law equation. So if we haven't got voltage, we know that in Ohm's law that current times resistance equals our voltage. And if we haven't got current, we know that in Ohm's law voltage over resistance gives us our current. Okay then. So what we'll do is we'll just go through these calculations just to make sure we fully understand it. So first things to do is when you've been given a situation like this, you need to determine what calculation you need to use. So it's always worth just starting to write it out. So P equals, and then we've got voltage and resistance. So we need to think about what calculations we use. So for this example, it's going to be V squared over R, because we can't use PIV because power equals current times voltage, because we've not got current. So we replace that current with our V squared. P equals 500 squared over 20. P equals 250,000 divided by 20. P equals 1250 watts, or as we normally do in electrical terms, 12.5 kilowatts, because 1000 watts is 1 kilowatt. Okay then. So that was using this equation, P equals V squared over R. The next equation then, so let's have a look at this one. So we've got P, and we've got I, and we've got voltage. So this is going to be P equals I times V, so the simplest one. P equals 20 amps times 200 volts. P equals 4000 watts, or 4 kilowatt. Okay, moving on to the next one. So P equals, and we've got current and resistance. So this one's going to be I squared times R. So P equals I squared, so that will be 10 squared times our resistance, which will be 30. So P equals 10 squared, which is going to be 100 times 30. P equals 3000 watts, or 3 kilowatts. Okay then, so that's just some basic power calculations. So there's those three variations, so it's important to remember, you can either just remember the three variations of the calculation, or if you can remember how to apply Ohm's law to it, that really helps as well, if you're missing the variables and you can't remember the three equations. So I hope that helps. Thank you.